Alright, hello, we're back once again to more Sudoku time. Excuse my voice. I wasn't really expecting to record this today. I've been busy the past few days. It's currently one day after I would record this, normally in fact. Normally I record this on a Wednesday. It is Thursday. But I got a little bit of time, so hopefully we'll be able to do this one. It's another rat run. You know how it is. You know, we pretty much only do these recently. I have been experimenting with recording a few other things. I just haven't actually gotten around to posting anything other than a rat run. But hopefully I will. Anyway, so let's get started. So, normal Sudoku rules apply, so we have to put the digits 1 through 9 in every row, every column, and every 3x3 box, which in these rat run puzzles are denoted by these dotted lines, since we have a lot of other stuff going on in the grid. This grid is very busy, but let's see why that is. So, aim of the experiment. Thinks the rat must reach the cupcake by finding a path through the maze. The path must not visit any cell more than once, cross itself, or pass through any thick maze walls. As well as moving orthogonally, Finks may move diagonally if there's a 2x2 space in which to do so, but may never pass diagonally through a round wall spot on the corner of his cell. So, if I enable my pen tool here, we can show that off. Basically, the goal of this puzzle, other than filling up the Sudoku, will be making a path for Finks the rat here to get from where she is right now to the cupcake. So the path might look something like that. And that rule about 2x2 space, so let's say Finks did something like this. That's completely allowed. She is allowed to do that by the rules of the puzzle. What she can't do is that, because that's passing through a rounded wall spot, and that's just not good. So, trap doors. Each rectangular trap door has a different total, the sum of its digits. Finks should not step on a trap door without first locking it shut, making it safe to cross. So I guess these are the trap doors we're talking about. So these each have a different sum, the digits on them, the digit on their squares. And Finks can't pass through them without first shutting the trap door. And I'm guessing that will be the buttons here. To make it safe to step on a trapdoor, Finks must first press all the circular buttons that match the color of the trapdoor. Digit on a colored button indicates how many buttons of that color contain that digit. Ooh, interesting. So these are like circles in normal Sudoku, so I'll talk about that in a bit. But basically, if we wanted to pass through the yellow trapdoor here, we could only do that if the path before that pass through all of the buttons. So we could do something like that. But if we don't pass through all the buttons, then that trapdoor can't be passed through. That's very interesting. And also that thing that it says about a digit on a colored button indicates how many buttons of that color contain that digit. So if this had a 3 in it, then 3 of these 4 yellow buttons would contain a 3. So it might be those, for example. And finally, test constraint. In this experiment, the correct path will be entropic, i.e. every group of 3 adjacent cells along the path must contain 1 low digit, 1 medium digit, and 1 high digit. So, if we have a path here, if this was low, then this would be low, and this would be low, because that's every 3. And then, for example, if this was high, this would be high, and if this was medium, this would be medium. I don't know why Steam opened up all of a sudden. Close that. Please. Okay. Steam loves to just open up randomly, and I don't know why. Anyway. So like, the line could be something like, something like this, because this goes low, medium, high, low, medium, high. Whoops. There. low, medium, high, low, medium, high, low. Sorry, my brain's still kind of trying to figure out how all these rules work together. But yeah, let's get started. I hope I can actually finish this. I like I said, my brain's kind of all over the place today, so if I can't finish this, well, one, you won't be seeing this, but two, I guess I'll try again another day. So, okay, well, very simple deduction here. The cupcake's right here, so Finks is going to have to pass through the blue trapdoor, which thus means that she's going to have to pass through all of the blue buttons. So anywhere where there's a blue button on like an obvious path, we can just draw that path in. So that is definitely going to be, in the puzzle. That will be in the puzzle. And this will be in the puzzle, definitely. Also, because that is in the puzzle, that means she's also going to have to pass through the red trapdoor. So that same thing applies to the red buttons. So she's going to have to pass through all the red buttons and the blue buttons. Definitely. She's going to have to pass through all the red before reaching this spot. And she's going to have to pass through all the blue before reaching this spot. AKA before reaching the cupcake, probably. That's very interesting. Wondering how that's going to work. Okay. The other thing I was going to say was that circles are very interesting. So that rule that said, where was it? Yeah, a digit on a colored button indicates how many buttons of that color contain that digit. Well, let's think about that, right? So there's 4 colored yellow buttons. So definitely, at most, they can only be 4. So they are from 1, 2, 3, and 4. But if any of them were 2, then that would say that there's 2 of these buttons that are 2. So let's say it's those 2. Well, now these aren't 2s anymore. But there's only 2 buttons left, so they're not 3s and 4s, so they'd both be forced to be 1. But that's saying that there's one yellow button that has a 1 in it, and that's just not the case. So none of these can actually be 2s. They're either 3 buttons and 1, or they're all 4s, which is possible. Okay. I can do that same kind of counting exercise with the other colors. Let's see. This, yeah, so red has 6 buttons in it. So they are from 1, 2, 3, 4, 5, and 6. They're not 6, because that would mean that they're all 6, and then these both would be 6, and they're seeing each other, so that's not going to work. They are not 5, because then... actually, could they be 5? No, they couldn't be 5, because then these 2 would have to be different from each other, and these 2 would have to be different from each other. So there couldn't be 5 buttons. So they are also from 1, 2, 3, and 4. Which is quite interesting because of the test constraint that said that the line must be entropic. So this is probably a low digit, a 1, 2, or 3. Can I disprove that these can be 4? If they were 4, then these would have to be different from each other, and these would have to be different from each other. So one of these would be 4, and one of these would be 4. That would force both of these to be 4s. Now, yellows can't be 4s anymore, so they're from 1 and 3. That can't be a 4, so that would be forced to be a 4. Let's see. So that would be... Well, they couldn't be a 3, because there's only 2 buttons left. So the buttons that aren't 4s would actually be forced to be 2s. So that is a 2 or 4, and that is a 2 or 4. And I think that's as far as we can get with that. So, no, I don't think I can disprove that those can be 4s. Can I disprove that these can be 4s now, maybe? I don't think so. Yeah, I don't think so. Okay, well, let me count how many blue buttons there are just for us to finish that thought train off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So that's not quite as useful. But it does mean that the numbers on the blue buttons are going to have to add up to 12. They're going to be some set of numbers. Oh, excuse me. They're going to be some set of numbers that adds up to 12. Okay, well, one thing I can say is that that set of numbers doesn't contain 9 or 8. Because if it did contain 9, there's 9 9s in the puzzle because there are 9 boxes in the puzzle. But there's no blue squares here or here. So somehow we'd have to put 9 9s in 7 boxes, which is not going to happen. Same thing with 8. We'd have to put 8 8s in 7 boxes, which is also not going to happen. So the most I can say about these, and I don't think I'm going to keep this pencil mark, but let me just see, is that they are from 1 to 7. Can they be 7? Barely, I think. That would mean that every single one of these boxes needs to have a 7 on a blue button. So that would be a 7, 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 that would be a 7. That would be a 7. And one of these two would be a 7. So barely, I don't think I can disprove that those could be 7s. You have to add up to 12, like I said. Oh, well, funny thing. This blue button has to have a different entropy than that red button, because they're 2 apart on Finks's path. And so are these. And so are those, actually. But those are both blue buttons, which that's interesting. So those are definitely different. Well, I knew those were different digits, but they're different entropies as well. So they can't both be low or both medium. Weird. Okay. I guess for now I'll keep that pencil mark. It's not useful. It's not useful, but I'm gonna keep it just so I remember. Just so I remember what I was doing. Okay. Let's see what I can do. Yeah, recordings. This happened. Okay, good. I've been having a lot of trouble with OBS and DaVinci Resolve recently. I'm trying to make a really big video for a different thing. But it's just not working. I don't think my computer can handle at that big of a video rendering all at once. Anyway. Oh, I'm silly. This is also part of the path because of that blue button. Can I... The thing is, yeah, any other blue and red buttons, I know she's going to have to step on them, but I just don't know how she gets on them and how she gets out. So like this one, she could do that, but she could do that, but she could also do that, so I don't know what to draw there. This is unfortunate. Can I prove that Finks, right off the bat, doesn't go there? Yeah, I can. Easy. So if Finks did go there, if she somehow went over here, we know she's going to have to get in this bit of the path at some point, but she can't, because now she can't get back into this box. There's no other entrance into it. She doesn't go there immediately, but she presses all the red buttons, so she needs to press these two before leaving this box. How's that gonna happen? Yeah, both of these red buttons need to be pressed before Finks leaves that box. Definitely. And then she's gonna come here. I'm guessing these two lines are gonna connect, but I don't know how to prove that. Still don't know if she's gonna have to press all the yellow buttons. Yeah, this puzzle's very complicated, actually. I might not be able to solve this right now. I mean, it's only been 15 minutes. I shouldn't discount myself that quickly. But yeah. Oh, huge. Wait, that's huge. Okay, that's actually huge. Look at this. Look at this this thing up here. That is massive, because look at this. If this is entropy A, let's say. In fact, let me write that down. Enable letter tool. If that was entropy A, then this is entropy B, and this is entropy C. And then it repeats, so it goes A, B, and C. So all three entropies are accounted for here. So there must be a high digit in one of these three, but we know what that is. It's a 7. So that thought that I said about if there's a 7 in blue circles, then they have to be in this specific way, it was actually correct. So we can fill those in from the thoughts that we had. Yeah, there we go. Those are all 7s. Very good. And now none of these can be 6s, because 7 plus 6 equals 13. One of these is 7, definitely. Yeah, okay, so far so good. So these are high. These are definitely high. I'm going to mark high digits as red. I'm going to mark medium digits as... let me see something. Nah, that's not very good. I'm going to mark medium digits as orange, let's say. And I'm going to mark low digits as green. Just so none of those clash. Well, actually, is that red going to clash with that red? I could mark high digits as purple instead. Let's do that. So purple is going to be high. Low is going to be green. And medium is going to be orange. I think that works. So now we know a little more about the entropy of the line. So this is high, this is something, this is something, this is high again. So this is another purple. It's not a 7, so it is an 8 or a 9. High, something, something, high. This is a 7, 8, or 9. Could actually be a 7. High, something, something, high. That is purple. It is an 8 or a 9. Okay. So we did something. We accomplished something. Yeah, the other thing is that there still needs to be a low and a medium here. So there can't actually be a 5. I should have seen that immediately. If there was a 5, then every circle that doesn't have a 7 would need a 5. And both of these would be 5s, and that's just not going to happen. So none of these are 5s. Which means one of these is definitely a 4. And the other is... a 1. Yeah. Yeah, okay. Which... yeah, okay, that works perfectly, actually. Because, yeah, 7, 4, 1, that does add up to 12, which is what we need. So, the missing digits are 7, 4, and 1. Or, 1 and 4. And then there's a 7 in one of those, and the other's either a 1 or a 4. But yeah, this is a 1-4 pair here, so I can unmark that, actually. This is not a 1 or a 4, then. Let's see. Okay. That is a 2 or 3. That doesn't make it impossible for there to be a 4 on reds. Oh, there we go. 1-4 pair. It means that's a 3. Which now means we are in the world where... oh, 3 in the corner, by the way. special winter animation. Very cool. We are in the world where the yellow buttons are 3s and 1s. So they are 3s and 1s, like that. Which means that's not a 3, that's not a 3. Can I do more with that? Well, 3 is low, so we'll mark that with green. Really thought I'd be able to do more with that. Oh, 1 second. That's actually a really cool start to the puzzle. I enjoyed that a lot. It's a really cool way of doing it. That pattern up there. That was really interesting. I like that. Let's see. Whatever entropy this is, if it's low, that has to be medium. Then high. Low, medium, high. That does make sense with the way that the 1 and the 4 are ordered. So we are in the right path. If this is... Oh, actually, one thing I realized. This... Not quite. Okay. If I knew which way Finks was going here, if she was going right or left, then I could say something about this part of the line over here. Because let's say she's going right. Then the path goes, this high, this high. So if this was low, it would go low, medium, high, in that order. So I could say the same thing about the path down here. It would go low, medium, high. So I could say that is low. So basically that would be the same entropy as that. But I can't say that. Well, I can say something though. That is the same entropy as one of those. Actually, no, that's not useful. That's obvious. I already knew that this was low or medium. Obviously. What I was trying to think about is if I can disprove that that's a 4. Can I? I feel like I might be able to. Let me walk through it again. So, if we were in the world where red contains 4s, then those two are 4. And that's a 4, definitely. That's a 2. No, actually doesn't do anything. Wow. I really thought that was going to do more. These have to add up to 6. So either... Yeah, okay. Either they're 4, 2, or they are 1, 2, and 3. So the red buttons definitely contain a 2, and either a 4 to go with it, or a 1 and a 3 to go with it. Don't know which, unfortunately. Well, here's something. What is this part of the path doing? It's either going right into a low digit, it's going down into a low digit, or it's going into the yellow trapdoor. Which would mean I can only do that if this path has already pressed all of the yellow buttons. But I don't think that's the case. No, I don't think so. I don't think this path can go up at all. Because if it does, then... how do I explain this? Then this button must have already been pressed. Which means either there's... let's see. Okay, let me think about this. If this path goes up, or upright, into the trapdoor, what I'm thinking about is how's it going to escape? Because that going into the trapdoor means that before that, this path has already pressed all of the yellow buttons. So this button must have been pressed somehow. But then I think that means, that means these two parts of the path are connected. So something like that is happening. So now, this part of the path can't go left. It would have to go right. It can't go down, because that button is already pressed. So it'd have to go right again. I feel like it's going to close in on itself. I feel like there's not enough space here for both of these paths to exist. But I don't know how to prove that. Yeah, that's difficult. Well, let me just think about what that would mean. If this path can't go up or upright, then it's going into a low digit. Which means after high would go low in this path. So this would go high, low, medium, which would mean that that is a 4. Which would mean that there are 4s in the reds. We should put a 4 there, 4 there, 4 there, and 4 there. And those two would be 2s. Now this would be low. It would be a 1. Because it can't be a 2 or a 3. So it would be a 1. That would be a 3. That would be a 4. That would be a 1. 4 there. I don't know how to disprove this. This seems like it's going okay. I just don't know how these two are gonna work together. So I don't know if I can prove that that is the case. It'd be really nice if I could. If I could prove that this path goes into a low, that would be kind of huge. Can I prove the other way around? Maybe that's easier, actually. Can I prove that there isn't a 4 on the reds? Because if there isn't a 4 on the reds, like we said, that they are from 1, 2, and 3. So they would all be low, definitely. But like we said, Finks must press all the red buttons in this box before leaving it. That is not going to happen, because that would be 2 lows too close together. That is not going to happen, because that is definitely low. So this would happen, and then she's not pressing all the red buttons. I think that proves it, doesn't it? So let's try that again. So these would all be low if there isn't a 4 on red. Now how does this path continue? It can't go here, because that's 2 lows too close together. It can't go here, because that's 2 lows too close together. It would have to go directly to Finks. But now that means Finks is getting out of this box without pressing all the red buttons, which we know is not the case. Okay, I think that's enough proof. I think we can now say that there is 4s on reds. So all of these are 4s. Those are 2s. Cool. Great. Now that means those are low. These are mediums, which makes them orange. And now we do know how the path works. So the path goes low, medium, high. Or the other way around. Medium, low, high. I don't know which way this path is going. But we can say that that's a low. Ah, there we go. Now we can say. So it does go medium, low, high. So the path is actually going left here. So after high, it's always a medium. So that means that's a medium, and that's a low, which makes that the 1, that the 4. That is a 4 now. Those are both mediums. That is a low. Low, medium, high. Yeah, okay, that works. Wow. That's crazy. That's low, and it's not a 4, so it's a 5 or a 6. That's low, and it's not a 1, so it's a 2 or... Oh, it's actually not a 3, so it is a 2. We good so far? We're good. Wow. That is crazy. That is a low. That is low. It's actually a 1 by Sudoku. That makes that a 3. So that is low. Okay. So this... Okay, let me think about this. So the path goes medium to low to high. Medium to low to high. So medium to low to high. Medium to low to high. So this part of the path is going left. This part of the path is going right. Which I think almost proves that these two have to connect. Because if they don't connect, that is barely possible, actually, weirdly enough, for them to not connect. If they don't connect, then literally this must happen. Like, exactly that. Because if they don't connect, then this path must get out through there. But to do that, it needs to press this. But now, where is this path coming from? It's not coming from anywhere, it's isolated. So I think these two do connect. Which is something. Wow, yeah, that's complicated. This is medium. Let's just go by simple things first. Low, medium, high. Finks now has to... Well, this part of the path needs to go into a low. It can't go into Finks, like we said, so it has to go there. Because that is a low. I forgot to mark these, but those are lows. And now, yeah, now it's, like, forced. Because, again, all the buttons must be pressed, so this will happen. So that is how the path moves through that box. That is high, and that is high. Those are mediums, and those are lows. So it goes medium, low, high, medium, low, high, medium, low, high, medium, low, high. Yeah, okay, that's good. So these are 5 and 6. That is a 1 or it's actually a 3, which makes that a 1. Which that is the one yellow button, so that is a 3. That's not a 1. Those can't be 7s, so the 7's right there. Whoops. 7's right there. Those are 8 and 9. That can't be a 1. Have we put the 1 on the blue? Yeah, we have put the 1 on the blue buttons already, so that's not a 1. That's a 4-7 pair. I don't need this working anymore. It's not very useful. Okay. This is getting complicated. I'm not gonna lie. Medium, low, high. Medium, low, high. Medium, low, high. Medium, low, high. Medium. The next square that we move to has to be a low. And it's one of 3 squares. It's either here, which would force it to be a 1, because it can't be a 2 or a 3 by Sudoku. It's here, which would force it to be a 2. Or it's here, which would force it to be 2 or 3. Okay, it's not very useful. Thought that was going to be better. Where do I go from here? It's getting complicated, man. We still... Okay, we have pressed a yellow button, actually. Just by, like, drawing the path in the way that it needs to. That yellow button has been pressed. Now, we don't know if that means all yellow buttons are pressed as a thing. I don't... Can I prove that this is going this way and not that way? I think it's really tough for this to go that way. Because that would mean this has to connect down there, while still leaving room for this to go somewhere. So it'd have to... Yeah, no, it's not going to happen. It's going to trap them. So this is going this way. So after a high is a medium. So that is medium. that is low. It is a 1, 2, or 3. This is a 4. It's not a 4. It's a 5 or 6. Can I say anything else about that? Not really. This can't be low, weirdly enough. It sees a 1, 2, and a 3. That doesn't mean anything. I just thought that was kind of funny. Let's see. 3 is in one of 2 squares down here. 2 is over there somewhere. Actually, over here somewhere. That's not 2. 3. Oh, I can put a 3 here. That is good by Sudoku. So that's not a 3. Yeah, I feel like I have a lot of 3s on the board. Can I put any more 3s down? Not really. 3's in one of these 2. 3 is in one of those 2, huh? That's something. Okay. Let's see. Actually. No, yeah. Okay. These, like we said, I think these 2 have to connect, which would mean this can't go left. Because if it did, it would bump, it would like trap this in, this part of the path. Because that's not supposed to connect to this. Those are going like opposite ways. So it would either trap it in or connect wrongly. Yeah, this can't go left, I don't think. No, it cannot. Okay, this can't go left, so it goes up or right into either 2 here or a 1 here. So either there's a 2 there or a 1 there. From that, it needs to go to a high, which if we go there, then that high is definitely that. Then you'd actually have to go to a medium, which you can't do there, so I'd have to do that. That would make a 5, 6 pair here. Then you'd have to go to a low, which is not that, so it would go there. That can't be a 2 or a 3, so that would be forced to be a 1. Weird, okay. So weirdly enough, okay, so there's 2 options. Either we go here right now, which puts a 1 here, or we do this weird loop-de-loop, and then this is low, blam, blam, low, and this is still forced to be a 2, because it's still forced to be a 1, because it still sees those 2. So in a weird convoluted way, one of those 2 is a 1. Definitely. Does that tell me anything? I don't know. That's either a 1, a 5, or a 6. Because if we go like this, then that's a 5 or 6. If we go like this, then that is forced to be a 1. So that's a 1, 5, or 6. From that, we'd have to go to a high, which we would get from there, an 8 or 9. From the high, we'd go to... Okay, let me keep following this path. From the high, we would go to a medium, which I think we're forced to get from here, because we still need to connect this part of the path to there, I'm pretty sure. Yeah, it could go straight up, actually. That would work. Or we could do something like this, that also works. Or, not that. Wait, actually, does that work? Wait a second. No, that's fine, actually. If this is low, then that just means the next digit has to be high, so it's either that... But it actually doesn't work. Okay, this path doesn't work, because then it goes high, medium, low. High, the next digit has to be a medium. It can't be there. So we'd have to be forced to do that, and now we're stuck. So if we go right, we're actually forced to go down. And then right. Which is actually the same as before. So we do know this is part of the path. We just don't know if it connects directly or if it does this. But we do know this happens. And one of those is small. One of those is a 1. If it's that one, then this is high. If it's that one, then this is high. So one of these is high. Don't know what that means. Now are we forced to go up? Because if we don't, either we're going down without having pressed all the trapdoors, we're going right, which, yeah, it traps us in this like lower part of the grid right here, or we'd be forced to do that, in which case we trap the cupcake. So we do have to go up, which, there we go, that gives us the path. So before a medium is a high, and before a high is a low. So that is a 1. I keep putting the wrong colors. Okay. And before a low is a medium. There we go. Great. And now before a medium is a high, so we do this. And that is low, and that is a 2. Is that correct? That is correct. Wow. That makes that a 3. Am I missing anything switch-wise? That can't be a 1. That's a 4, actually. Because we've already put the blue 1 switch. Yeah, these are just the 4, 7 here. I can't do anything with those. This can't go right, or it'd bump into that too early. So it has to go up into that 3. Now this 3 needs to go to a high. Can it get it from here? It could. I don't see why it can't. But then it has to go to a medium, so it would have to go there or there, and then into a low, which it could get from that 3, and then into a high. Okay, I don't think I can prove how this connects to that quite yet, but I do know that they connect. I'm pretty sure. I'm pretty sure that that is correct, that they do connect. Right. I'm sorry. That's all the mediums for this row. It's 4, 5, and 6. So everything else is either high or low. Don't know what that means. Let's see. 7s. We have a lot of 7s. Can we finish up some 7 stuff? Cannot. One of those two is a 7. What other digits do we have a lot of? We have a few 1s. 1's in one of these two. 1 is in one of these two, which could be interesting, but it's not interesting yet. This has to go into a low. No, into a medium. Yeah, because after a high goes a medium. So wherever it goes into a medium. Can't really do much with that, unfortunately. Oh, 2 by Sudoku is there. That's good. Any other 2s by Sudoku that we can do? Perhaps? Yeah, 2 is in one of these two. Puts 2 in one of these two. Not great. Yeah, I'll keep them. Could be useful for later. That could be a 2. That might be a 2. Could be. 3. Oh, my bad. 3 by Sudoku is here. Which means 3 by Sudoku is... one of these two. Okay. Yeah, barely. Okay. Are we only missing 2 3s? Yeah, we're only missing the 3s down here. We can't resolve those yet. Well, okay. Now we know something. This part of the path doesn't come from there. 1, because that would be 2 lows touching each other, and 2, because it would bump into itself. So it comes from up. And then, what? This probably connects to that. So those 2 need to connect. This needs to go into a medium, so it can't go down. It goes there or there. Don't know which. This comes from a high, which could be anywhere, really. This could be a high, this could be a high, this could be a high. I feel like somehow we're still gonna go through the yellow trapdoor. I feel like that's a very Marty Sears thing to do, to actually force us to go through the trapdoor in a weird roundabout way. 4 is one of these 2. It's not very useful. Yeah, it's the only 4s left. It's these. Am I recording alright? 46 minutes. I mean, not terrible. I feel like we've done a good amount of stuff, but the problem is I don't know how to continue. This... no. This comes from a high digit. Yeah, before a medium is a high. So one of these 2 is high. Neither of them are 7s. I don't know what to do with that. One of these is high. Then it needs to go to a low, which is probably going to be one of these 2. Excuse me. My bad. Okay. Let me try a different angle. I don't know which angle is the problem. Okay, let me try this angle instead. After a medium, we need a low. So either that is low, which would force it to be a 2, since it sees 1 and 3. Or that is low, which would force it to be, a 1 or a 3. It's not very useful. Is it? Actually, it might be. Hold on. If we go this way, then we need to continue going this way, because that's a corridor. So this would be low. It would be a 2. This would be high. It's not a 7. It's an 8 or a 9. That would force that to be a 1. That to be a 2. I can't see the problem with that. Gosh darn. I cannot see the problem with that. What about the other way? If we go down, then this is low. It's a 1 or 3. Then it needs to go into a high. Which could be anywhere, really. Any of these 3 could be high. Wow, yeah, I'm kind of stuck. This was a 3-star difficulty. So I'm not too surprised that I did get stuck eventually. It did seem to be going too well for too long. Let me mark some stuff. I'm here, might as well. These are 5, 6, 8, 9. These are 1, 5, 6, 8, 9. That's not a 1. 1 is one of these 2. Yeah, 5, 6s, 8s, and 9s, and to a lesser extent 1 seem to be the culprits here for a lot of the weirdness. These are not 5 and 6 because of that 5, 6. This is 1, 2, 8, 9. It's not a 1 actually. So one of these two is a 1 in that row. These are 1, 5, 6, 8, 9. Those aren't 1s. This is not a great way of doing the puzzle, I'm gonna tell you, but it seems to be working. I seem to be getting something out of this. 5, 6, 8, 9 there. Never mind. We ran out of things. Unfortunately, we have run out of things that could have happened. Very, very sad, I think. Oh, that can't be a 5 or 6. Because the 5, 6 pair here. So that is actually high. Wasn't there another... Yeah, this is high, definitely. That is an 8, 9 pair, which means these aren't 8s and 9. Ooh, okay. No, we might be getting somewhere. Because these are now mediums. Which means this is not medium. Because that's a 5, 6 pair. Ah, there we go. Okay, we got somewhere. This is not 5, 6. It is high. Which means the path doesn't go there. It must go here. Okay, dude. Okay. We've gotten something, I think. These being 8, 9 means these aren't 8s and 9s. So they are both medium. They are 5 and 6, which means this is not 5, 6. It is high, which means this is medium. It's not 8 and 9. Okay, 5, 6 there means this is not a 5 or 6. We got a 1, 8, 9 triple there. It's not quite as useful. But, let's see. This, that's interesting. This medium needs to go into a low. But then it needs to go into a high. So if it goes left, that high is going to be this. If it goes down, that high is going to be forced to be that. And then it's going to be forced to connect here, directly. How can I disprove that? I feel like my job right now is to disprove that, and I don't know how. Because I think this is what's going to happen. Because again, it's Marty Sears. He's going to do some weird stuff, right? He's going to somehow force me to press this button in this part of the path, and then somehow use this trap door just to connect these two later on. That's exactly what he's going to do. I am positive that that's what's going to happen, dude. It's Marty Sears. You got to expect the unexpected, alright? This is an 8 or 9. Which might be interesting, because all the highs in this column have been taken, so it means, well, we're gonna have to pass through at least one of these, because we need to get to the cupcake. So whatever we do pass through is not gonna be a high digit, which is something to think about. Yeah, that's something, alright. Boy. Let's see. This is 2, 5, 6, 8, 9. That's not useful. It's not useful. I'll keep it though, it's kind of funny. Let's see. It was going really well there for a second. Still good. It was going real well there for a second, and then it just stopped, unfortunately. That is loud. Can I get that feeling back real quick, please? That'd be nice. That'd be cool, I think. What is this? This is not a... This could be a 1, can't be a 2, 3, 4, 5, 6, 8, 9. Okay, that's not useful. But maybe... Oh wait, it can't be an 8 or 9. Oh, my bad. These aren't 8s and 9s because that 8, 9. This is 1, 2, 5 or 6. That's not a 1. Oh boy. feel like we're close. I feel like we're really close to figuring something out here. Don't know how to get there. I do not know. What are these from? Real quick. These are from 3, 5, 6, 8, 9. 5, 6, 8, and 9 are like I said, they're the real culprits here. They're the real bad boys. The cupcake. We're gonna end up at the cupcake for sure, right? So whatever the cupcake is, I think is important. Because if the cupcake is low, then the digit right before the cupcake is gonna have to be medium. If it's high, the digit right before is gonna have to be low. Which means it's one of these two. If it's medium, the digit right before has to be high. It's gonna be that. I don't know. One of these two is 3. If I could force the cupcake to be a 3, that'd be really cool. I don't see how to do that quite yet. Oh boy, how long am I recording? 56 minutes? Alright. Still on schedule. As if I have a freaking schedule. I just filmed it. I'm just here. I don't know. This goes into a high. That high goes into a medium. And that medium goes into a low. So if we go right, can't go up, so we're going to be forced to go into one of these two. And then there. And then here, I think. Yeah. Well, yeah. Or we go straight there. Can I prove that that's wrong somehow? I don't think so. I think that's wrong. I feel like that's wrong. Oh, my bad. One thing. This must go into a medium. It's not there, and it's not there, so it is here. Mediums go into lows, so that must go there. Lows go into highs, which must go there. So that's a low, which means it is a 1. Okay, yeah, I should have just been looking closer at the path. That forces that to be a 2, which means this is a 1, and now we're back. We are so back, actually. Are we so back? We are so back. The path continues. It goes here. Now, what? Now we must go into a low, but that low is going to have to go into a high. So if we go there, we're trapped. So instead we go there, and then we go there, and then we go here. So we don't actually press all the switches. Is that right? That feels wrong, but that looks right. Low, high, medium, low, high, medium, low, high, medium. That feels wrong. It feels like Marty Sears would want me to press all the switches. But you know what? That's too much meta puzzling. Let's not do that. Surely that's not how you solve the puzzle, by being meta and weird about it. No one likes meta. Yeah. Okay. Let's see. Done. What does that tell us? Does that tell us the position of any 1s remaining? I feel like it could have, but it didn't. It really did not. There's a 1 in one of these two, but we already knew that. Alright. 8, 9 paired there. 8, 9 pair here. 5, 6 paired there. 5, 6 here. 8 or 9 there. Okay. This goes into a low. That low goes into a high. Nope, still don't know. This goes into a low. Nope, still nothing. Gosh, darn. Oh, my bad. I forgot the entire point of the trapdoors. We need to press all the red switches. So if we go there, then we're gonna go here. But now there's no way we're gonna get to that red switch. So instead, we need to do that. Yeah, we do need to do that. And then we need to go into a high, and it's not there or there, so it's gonna be there, which makes that a high. So that is 8 or 9. Then we need to go into a medium, which unfortunately I still can't say that it does that. It could go here, and then there, and then there, and then there, and then there. Well, actually, there's a... Yeah, dude, that could happen. That is crazy. I know this is gonna connect to that, but I don't know if they do it straight or if they do some kind of weird loop-de-loop. Because they might do some kind of weird loop-de-loop, and that's what I'm worried about. I'm worried about the loop-de-loop. Why am I so worried about the loop-de-loop? Because we go high, medium, low. So we could go high, medium, low, high, medium, low, high, medium. That works. That actually just works. That super works, and then that will connect like that. Why does that work? Oh, I hate that that works. Marty, why does that work? Marty Sears, you absolute legend. One thing about that being high is that there's no more highs in this column. Which is something, I guess. I don't know, dude. I don't know. Ah. I'm losing it. Am I? I feel like I had it there for a second, but now I've lost it. These are... One of these are 2. Not that much. Come on, brain. Let me think about that path again. So, high, medium, low. High, medium, low. High, medium, low. High, medium. That just works. That just works, actually. I hope my path is correct, because the thing is, the checker only checks digits. It doesn't check the path. Is there a reason I can't do this? Because that would force that to be a high. That would need medium. So we do that or that, and then we connect there, and then we connect here. I don't know why that's wrong, but now I feel like that's wrong, because this is much sillier, and I don't know about you, I think Marty Sears is pretty silly, honestly. He likes doing some silly stuff from time to time, and that seems like the exact kind of silly that he would pull off. Don't know how to prove that. Just don't know. Is there anything I can do that I'm not noticing? I feel like I've looked at everything. I feel like I've looked at literally everything. Oh, one thing I can say is that there's a 3 in one of these 2. But there's also a 1 in one of those 2. So these are actually a 1-3 pair. They are the lows. Which makes this a medium. Which might be huge. Is it huge? Please tell me it's huge. It's not huge, dude. It's not huge. I thought that was going to be huge because I thought I could prove that that can't be in the path, but it can, because low does come from medium. And then that would be forced to be a high. Probably a 7, but maybe not. Gosh darn. Alright. Well, no, that's still okay. Oh, 5-6 pair. Means that's not a 5 or 6. Okay, that's something. That's not a 5 or 6, which means a 2. Okay. We're kind of back. For like a second. just let me have a victory, okay? Let me have this small victory for a second. While I think what the heck that means for my life. None of these are lows now, because that's all the lows in this row. Really thought that would do more. Can we finish off the twos finally? No, two is still one of these two. Still can't say which one is the two. Two is one of these two. There's an X-wing of twos right there. Don't know. Okay, well here's one thing I haven't thought of yet. It seems like closing in on this being the end of the path. That is going to get to the cupcake, eventually. But it still needs to press these two buttons. Those two must be pressed. One of them is medium, the other is high. So if we want to go from one straight to the other, we're going to have to go high and then medium. In that order, because that's the order the path goes in. What does that tell us is the thing? I don't know. High, medium goes to low. Low goes to high. Ugh. Okay. Yeah, I'm starting to lose it. Can I prove that this isn't a 3? Maybe. If this is 3, it must come from a medium, which means it comes from there. But then mediums come from highs, and highs come from lows. So you'd have to zigzag like that. And then lows come from mediums. So whatever this comes from is going to have to be a medium. Yeah, no, I don't know how to disprove that. If I could disprove that's a 3, or prove that that's a 3, that would be huge. I don't see how to do that. Yeah, I'm sorry, I feel very stuck right now. I feel like every time I get something, it gets snatched away from me like that. Marty Sears, you absolute villain, you. Whatever, what is this? 1, 5, 6, 8, and 9. Let's just mark some more stuff, dude. These are from 2, 5, 6, 8, and 9. Maybe by just marking more things, I'll see what I'm missing. I don't think so, but honestly, at this point, I don't know what else to do. These can't be 5 or 6s, because they have 5, 6 pair. Oh, that is high. Okay, that's something. That is something. That is always high. Okay. If that's high, then that is a 7. If that's high, then that is a 7. I already knew that much. Let's do some more marking. These are... Whoopsie. 2, 5, 6, 8, 9. These are from 4, 5, 6, 7, 8, 9. Oh, there we go. Okay. We got something. This can't be the path. Because if it is, that's low, so that would be forced to be low, but it can't be. So that can't be on the path, which means this can't be and this can't be. So the path must come through here, definitely, because that's the only way of getting to this box other than that is left. Now, if the path comes through there, it must follow the rules. So if that's low, that's going to have to be high. If that's medium, that's going to have to be low, which it can't be. So that can't be medium. And if that's high, that's medium. So the only thing we got from that is that that can't be a 5 or a 6. Wonderful. Well, this is medium or high. Oh, wait. We now know we're not coming from here. So I think that means... Yeah. Yeah, okay. We must go directly to the other button, because if we don't, we're either going to do that and block off the button, or we're going to do that and block off the button. Well, if we do that, we either block off the button or the cupcake, because if we go back for the button, now it's impossible to get to the cupcake. And we can't do that anyway, because we haven't pressed all the buttons. So we go down, which means we don't go medium to high, we go high to medium, because that's how the path works. And now this is low, so it is a 1. Okay. I think that is going to do it. I think that will solve all of our issues. That is a 7 now. That is a 4. These aren't 1s. They are medium. That is not a 7, like I said. That's not a 4. Oh, Lord. Okay, this medium goes to low. Yep, so we're going to go there. Low goes to high. I don't know. It's either there or there. Well, high goes to medium. Yeah, I think we're going to zigzag, but I can't tell quite yet. So instead, let's just do some more marking. This is medium, because it is a 4. That's not a 1. Which is... Yeah, that is a 1 now, because that's the only place in the box left for a 1. That's a 3. By Sudoku, that is a 1. That's not a 3, so that is a 3. And that's low, and I think that's all of the low digits done. Yeah, 9 3s, 9 1s, and not quite 9 2s. We're not quite done with the 2s yet, but can we be done? May we be done? Are we allowed to be done? Medium, low actually comes from medium. So whatever square we come from here is going to be a medium. Can we do this now? Does this work? Because now it goes medium, low, high. Which means that's a 2. That's an 8 or a 9. And then it must go medium again. And then straight there. If we don't do that, then we go there. And then we go medium, low, high, medium, there. Both still possible, unfortunately. That's high. These aren't 8s or 9s because of those. Ugh, we're almost there. We're almost there. I can feel it. I can feel that we're almost there. How do we finish it? Don't know. How are we gonna finish this? I don't know. We've pressed all the blue buttons. We've pressed all the red buttons. We don't care about the yellow buttons, because we missed that one. That just means these 2 squares can't be visited. Definitely not. Oh, which I think resolves this, doesn't it? Does it? Hold on, does it? High, medium, low. High, medium, low. High, medium. No, it doesn't. My bad. I thought we went through that for some reason. How is this going to be resolved then? Are we fine? We're fine. How are we fine? I'm almost mad that we're fine. Because at least if I had done this wrong, I would know what to look for. Are we done with 4s, by the way? Yeah, we've put in all the 4s. Are we done with 7s? We are. We've put in all the 7s. How is this going to resolve itself? I feel like everything is unresolvable now. But something has to give. Something has to give. But what? But what? What the fuck gives? Did I? Yeah, I marked that path when I shouldn't have. My bad. That path doesn't exist. We don't know where this goes yet. Hopefully I didn't miss anything. That little jiggamarole. That's high. I missed coloring that, I guess. And I missed these two. Yeah, those aren't 8. I don't know. I don't know how to finish this. We're so close to finishing it, though. Like, I have to try. I've been recording for 1 hour 16 minutes. 5-6 pair there. I didn't see that, I think. Okay, that does it, I think. Yeah, because now there's an 8-9 pair here. That's not an 8 or 9. Which... Is that enough? Please tell me it's enough. That's not enough. That is enough. 2, 5, 6 pair. So that is not a 5 or 6. Which finally tells us the cupcake is high. So we do go this way. So it goes low, high, medium, low, low, high, medium, low, high, medium. Oh, my bad. We don't do that. We do this. My bad. Yeah, because now that works. Low, high, medium, low, high. Okay, good. That's something. That's something resolved at the very least. But now what? We've once again hit the wall of... Got something. Now what? Don't know. This comes from a medium. That medium comes from a high. Oh. This can't go left anymore. No, it can't. Wait, my bad, it can't. Because it goes medium, low, high. No, that still works, dude. Come on. Medium, low, high. Medium, low, high. Get tired of your games, Marty. What am I missing? What am I missing? What am I missing, Mortimer? That's not your name. Is it this? Is it this? I still don't know how to resolve those, is the problem. I don't think anything changed up here, because I did this stuff down there, did it? High, medium, low, high, medium, low, high, medium, low, high, medium. That still works, dude. And then here, high, medium, low, high, medium, low, high, medium, low, high. Those both still work. How am I going to disambiguate that? I don't understand. I don't get it. I don't get it. I don't get it. I don't get it. Is it numbers? I put in all the 1s, 2s, 3s, and 7s. And the 4s. Unfortunately, I haven't put anything of any other digit. In fact, I have no idea how the 5, 6, 8s, and 9s are even going to disambiguate themselves. I must be missing something. The trapdoor sums. Oh my god. I forgot all about that. Every trapdoor has a different total. Oh my lord. Okay. Well, shoot. Let's think about that then. What can this total be? It can be 8 or 9. This one can be 7 or 8. This one can be 6, 7, 9 or 10. Okay. So what that does mean is that this can't be a 5 with that being a 6. Am I missing anything else? Like that I think that is it, because I did forget about that rule completely. But digit on a color button indicates how many. I've done all the colored buttons, haven't I? Am I missing any colored buttons? I'm not. No. I don't think so. No, buttons are fine. Let's see, test constraint. Yeah, okay. No, it must be the doors summing to different things. But how is that going to help me? This is what I'm thinking here. This is 8 or 9. This is 7 or 8. If this sums to 8... Well, it can't sum to 8, because that can't be a 7, actually, my bad. If this sums to 7... This must be 8. Okay, hold on. This must be it somehow. Okay. If this sums to 7, then that means this is a 6. But now this can't sum to 7, so that is a 6. Which makes that a 6. But now this sums to 8. So this must sum to 9, which makes that a 6. And that a 6. And now 6 can't go anywhere in this box. Let's go. Okay, so this doesn't sum to 7. This is not a 6. Can it sum to 9? If it sums to 9, then that's an 8. That means this can't sum to 9, so that is a 5. But now this sums to 8, so that must sum to 7, so that is also a 5. And now 5 can't go anywhere in this box. Okay. This is not an 8 then. So that is a 5 or a 9. That's better. That is better than what we started with. Now, okay, now what I'm thinking of is, can either of these sum to 8? Because I think in both of those situations something went wrong. Because if this... Yeah, okay. If this sums to 8, then that's a 6. Now this can't sum to 8, so that is a 6. 6 can't go anywhere. So that can't sum to 8. That's a 5. Which is going to resolve absolutely everything. That's going to resolve absolutely everything. That does it. Wow, that little rule that I completely forgot about is what unravels the entire puzzle. I completely forgot about it. I really, really did. Now, I don't think this is going to finish it off, because the path is not done yet. So we still have a little more work to do, but that does most of the work. Like, most of the work. Okay, now let's color some stuff. So 8s are high, 6s are mid, 9s are high, and that's all we know right now. Okay. Wow. I did. I really did forget about that rule. I'm not playing it up for laughs. I actually did just forget about that. Okay. So. What does that tell me? Can this work now? So. Yeah, I don't think we can go red anymore. Because if we do, we gotta go... No, yeah, we can't go right because that's just not high. So we do go there. So that part of the path is done. Now how do these two connect? Let's see. High, medium, low. So high, medium, low. High, medium, low. High, medium. That still works. Wait, how am I going to disambiguate that? I feel like that can't be disambiguated. Because don't both of those work? High, medium, low. High, medium, low. High, medium, low. High, medium. Or I could just do that. medium goes to low. Okay, we can't go left anymore because it would go medium, low, medium. So we do go down. Low goes to high, so we go there. High goes to medium, which I don't know yet, but medium goes to low. Okay, we literally have 6 digits left, and I'm still trying to wrap my head around how this is working. Did I do something wrong with the path? I must have. Hold on. Okay. Medium, low, high. 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 And then somehow these two are going to connect. And we go medium, low, high. Medium, low, high. And then somehow these two are going to connect, and we go low, high, medium, low, high. My god, Marty. Can't you just give up? This puzzle just doesn't give up. We're right at the end, and it's still fighting on. Commendable, for sure, but also, like, my god. Well, we're here. Can we go? No. We gotta get to a medium next, but that medium needs to go into a low. And that low must go into a high. Okay, what I'm thinking of is, I think that low must be this one. Because if it's not, if the next low in the sequence is not that exact one, then it's going to be one of these 4. But whatever it is, it's going to have to connect to a high next. And the only one it can connect to is that one. But then, we're stuck, because that high needs to connect to a medium. And it won't be able to, because these are going to be blocked off, because we got there from here. Yeah, okay, no. The next medium, the next low in the path must be that one, which means the next medium is going to have to connect straight to it, which means that is going to happen. Which means that is medium. And that is low, and that is 6. I'm still not satisfied, because the path is not complete. I must be missing something. I must be missing something. I must be missing something. Did I draw my path wrong? Because I don't know how to disambiguate this. I still don't. Because like I said, high, medium, low. High, medium, low. High, medium, low. High, medium. Or this. I don't know which one's correct. I don't know which one's correct. Did I do coloring wrong, maybe? Let's see. If I highlight all the greens, those are just 1s, 2s, and 3s. If I highlight all the oranges, those are 4s, 5s, and 6s. And if I highlight purples, they are 7s, 8s, and 9s. So no, I did do my coloration right. What am I missing, dude? The thing is, the puzzle's not done yet. The numbers are right. But the path's not done. Oh, the blue button! We're missing that blue button. We need to press it. So that is how the path works. Oh, Lord. Okay, that was a lot. That was a lot to keep track of, let me tell you. That was a lot to keep track of. But I enjoyed that. I enjoyed it immensely. It was very complicated. I don't know if I'd rate that 3 stars. It's not like a high 3 stars, for sure. I don't know if I'd rate it 4 stars, but it felt 4 stars. You know, just because of how much stuff you had to keep track of. Good puzzle. But wow, that is a nasty ending. That is a very, very just evil ending, honestly. Evil is what I'd call that ending. But very good. Very good. I love that. We can now finally read this. Experiment completed successfully. Cells visited 57, buttons pressed 21. Despite being unfamiliar with the buttons, Sphinx showed no reluctance in pressing those necessary to lock the red and blue trapdoors, and was quick to realize that she needn't concern herself with pressing all the yellow ones. I hope that she enjoyed this task. Elliot keeps reminding me that it's crucial that Sphinx stays motivated for what's to come in the next phase. Oh! Well, there we go. A reveal that there actually will be a next phase. Oh, that's huge. That's actually huge. So phase 2 is not the last phase. Very good to see that. Very good to know that. I love these puzzles, man. They're very, very good. That was hard. I'm not gonna lie. But I enjoyed it very, very much. I like how everything works together. It was very interesting how the buttons indicating how many, like, they're just on buttons indicating how many buttons that color had that digit. That was actually really easy to figure out. Like, that was not a hard part at all. But then everything that came after was. And yeah, I completely forgot about that rule with the trapdoors. I really did. There was just a lot to keep track of at any one moment. And if you forgot any of it, you couldn't progress. I enjoyed it a lot. Very good puzzle, as usual. Marty, you evil genius, you. Let's solve it, shall we? Let's, like, finish it off. Digits on the path in column 8. So yeah, we did actually have to finish the path to get the solution code. So it's 936418. Yeah. 936418. And there we go. Woof. Yeah. Hard puzzle, but I enjoyed that immensely. Clever girl. Anyway. And yeah, she did visit a lot of cells, didn't she? She went all around the freaking place to get to that cupcake. That is a big path. I like that. Anyway, that's it. Wow, that took a little longer than I thought it would, but honestly, 90 minutes is not terrible for these rat run puzzles. They require a lot. They require a lot of thinking. But yeah, there we go. I guess I'll come back next week. Maybe I'll do another puzzle just outside of rat run. Between here and then. I don't know if Marty himself has posted any. Oh, he has actually. He has posted quite a few puzzles. Or no, that's just solved puzzles. He has, yeah. He's posted a few puzzles other than the rat run. So maybe I'll try doing some of those. Maybe just some other random puzzles. Oh, this one seems actually kind of cool. Ooh, the rules will be discovered as you go. Oh, that actually sounds cool. Maybe I'll do this one. Okay, so yeah. That's it for now. Good night.